All right, first question. A bag contains 4 red marbles, 5 blue marbles, and 3 green marbles. Write down the ratio of red to blue to green. Everywhere you have the 2 is where you put the dots. So you want the number of red marbles first. There were 4 red. Then we need the dots. Next you want blue, which was 5. Dots again, and then green, which was 3. So you're just putting those numbers into ratio form. So each one of these will be similar. You'll just be maybe changing the order, maybe only using 2 of them. Just reading exactly what it says, putting the number in for the color that it says. Okay, question 2. Let's do the first one. If we have a missing box, what we have to do is use the numbers that are there, so the 3 and the 12 would go together, to find out what you are multiplying, or sometimes if the numbers are getting smaller, you would divide. But most of the time, when they're getting bigger, you multiply. So what do I multiply 3 by to get to 12? 4. So if I multiply that by 4, the 10 needs to be multiplied by 4 as well to find the missing number, which would be 40, correct. So it's a lot like fractions, it's just written in ratio form instead. Question 3. To write an equation for the following scenarios. Ooh, write an equation. I was expecting that to be a simplify question. Where are the simplify ones? I don't think we need to write an equation. Let's practice simplifying. To simplify a ratio, you're wanting to see what you could divide each of the numbers by. So 7 and 28, you could divide by 7. 7 divided by 7 goes once, and 28 divided by 7 goes 4 times. So you're dividing both numbers on the top by 7, and you get the numbers below. Now, if you are looking at the numbers and you're going, I don't know what to divide by, you can get your calculator to simplify ratios for you. When there's only 2 numbers, you can't do it with the 3 number one, like the one I had before. But if there's 2 numbers, what you do is you type them in as a fraction. So you go 7, fraction button, 28, and you press equals, and it will give you the answer as a fraction. You just have to put the dots back in. So it's 1 dot dot 4. Okay, so that's a bit of a quick help kind of thing if you're ever stuck. However, there is, let me see if I can find one. If you have a question where I'll make one up. So let's say we had 8 dot dot 4. If you were to type that in, you only get a whole number 2. Now you're going to need 2 numbers in a ratio. If I only get 1 number, what do you think the second number is? A 1. Okay, so it should be 2 dot dot 1. And hopefully that's easy to see from here because you're dividing both of these by 4. So it should be 2 there and 1 there. So anytime you get a whole number, it means the second number is a 1. Harder ones of these involve fractions. Again, you can do these on the calculator. Do you want me to show you without the calculator first though? Yes? All right, without the calculator, you need to multiply by the lowest common denominator. So see how I got 2 fractions, a 4 and a 7? Easiest thing to do is multiply them together. So 4 times 7 is 28. And I'm going to multiply this fraction by 28, and I'm going to multiply that fraction by 28. Okay, so here I go. 1 over 4 times 28 makes the first number a 7. And then 2 over 7 times 28 makes the number an 8. Okay, so you just multiply by the lowest common denominator. To do the whole thing on a calculator, this is like my quick little cheats thing, you divide one fraction by the other. So you start with 1 over 4, and then you go divided by 2 over 7, and there it is, 7 over 8. And that will even work for the mixed numeral. You just do mixed numeral divided by the other mixed numeral, and it will give you the simplified ratio. Okay, yes, Max? No. Which is why if you're doing the shortcut on the calculator, you're going to be fine. As long as you remember how to do it. Okay, question 5. First change the quantities into the same unit and then express each pair of quantities as a ratio in simplest form. Ratios normally don't have any units. All the ones that we just did, they were just numbers. There was no centimetres or litres or anything in there. They don't normally have units. So if these ones do, we have to make the units the same so that we can get rid of them. All right, I have millimetres and centimetres. To keep life easy for myself, I usually take the bigger unit and change it into the smaller one. That way I can avoid decimals. Okay, so 3 centimetres is how many millimetres? 30, because what you do is you times by 10, so that's equal to 30 millimetres. So my ratio is 24 to 30 before I simplify it. Okay, just I've changed the units to be the same, but now I want to simplify the numbers down. So you can either type it in your calculator as a fraction, or both of those numbers can be divided by 6, which would give a 4 and a 5. Question 6. Divide 63 in the ratio 4 to 5. So we want to add together the parts of the ratio. 4 plus 5 is 9. And you may remember Mr. Harris writing this on the board. He taught this topic. And so he put those together and he put the 9 on the bottom underneath both of those numbers. Because what you need to do is you need to put the 4 over the 9 and you times it by the 63. And then you will put the 5 over the 9 and you'll times that by 63. And that will tell you how much each person in that ratio would get. Does that make sense? All right, so let's just type that in then. We go 4 over 9 times 63 is 28. And the second person just changed that 4 to a 5. And they get 35. As a bit of a check, if you add these two numbers together, it should give you 63. If it does. Okay, so question B there would be the same. Question 7. These are our scales if we have a map or a house plan or something like that. Okay, so a map has a scale of 1 to 60,000. Find the actual distance for each scaled distance. So if we have a measurement on a map, the 9 centimetres is the measurement on the map, you need to times by the ratio, the 60,000 up here, because it's going to be a much bigger measurement in real life, correct? So this one is going to be 9 times by 60,000. When I do the next question though, if you're going from a real measurement back to a map, you will divide because it's getting smaller. But let's finish this one first. When I times that together, it's going to be a really big number. That's because the units of that question are centimetres, because whatever was used here, centimetres, is going to be centimetres in my answer. So 540,000 centimetres. Who would ever measure that many centimetres? So change it into a bigger unit. Can we change it into metres first? So if I divide by 100, that would be 5400 metres. Should I make it better than that even? Yeah? Kilometres. What would it be? Divide by 1,000. So yes, 5.4 kilometres. So it makes much more sense to say 9 centimetres on the map is 5.4 kilometres in real life as opposed to 540,000 centimetres. Everyone's going, I have no idea what 540,000 centimetres looks like. Okay, so let's do the other one going the other direction. A model of a building has a scale of 1 to 300. Find the scaled length for the actual measurement that we've been given. So the actual measurement is 21 metres, real life measurement. So that means I'm going to divide this time, 21. You divide it by the number in your ratio, the 300. This time when you divide it, you'll get a very small number. That's because that 0.07 is in metres. And who would measure metres on a building plan. Nobody measures meters on a building plan. We need to change it into a more realistic unit. So let's times it by 100 to put it into centimeters. 7 centimeters on a building plan makes much more sense. Okay? What else do we need to do? Question 9. Determine the scale ratio in each of the following situations. This is actually very similar to a question that we've already done. We need to make sure that the measurements that we have are in the same unit and then simplify the ratio down. So, should I change them into centimeters or should I change into meters? Should I change this one or this one? It doesn't matter. You want to change that one? That's the smart choice. Good job. Change the bigger one. So 40 meters. I want to put that into centimeters, so I'm going to times it by 100. So that's 4,000 centimeters. Now that they have the same units, I can write them as a ratio. 5,4,000. I don't need the centimeters. Please don't write centimeters on there, because once they're the same, we get rid of them and we just use the numbers. Simplify it down. I can divide by 5. So that would be 1 on this side, and 4,000 divided by 5 is 800. Okay. Worksheet B. This is now talking about rates. Ratios don't have units, the ones we're just doing no units, but rates must have units if you want to get full marks. Okay? Express each of the following as a simplified rate. 24 millimeters of rainfall in 3 days. I write these down as fractions with the units because I find that it helps you to remember how to write the units in your answer. So I write the fraction like this. I go 24 millimeters in 3 days. That fraction is like saying per. 24 millimeters per or in 3 days. Now you want to divide the two numbers. 24 divided by 3 is 8. And to write the units down, the one on top goes first. It will be millimeters per, to use the slash for per, millimeters per day. You must have the units. The 8 is not enough. You must have the units for these questions. Question B will be something very similar in dollars per hour. Question 2, find the average rate of change for each situation. So that's still just finding a rate. I think I'll leave that one for you because that's still a rate. Maybe I should do B, that's a trickier one. Russell was 115 centimetres tall when he turned 6 and 187 centimetres tall when he turned 18. I need that as a rate. His height is changing over years, right? So I need how much has, in centimetres, how much has he grown in centimetres on the top? That was very messy. Let me try that again. Centimetres on the top. And I need the years that have passed to be on the bottom. So let's have a look. He started out at 115 centimetres and he grew to 187. How much has he grown? So he's grown 72 centimetres. Great. How many years did it take him to do that? So he was 6 and he was then 18 for this one. So yes, it's taken him 12 years. So now we divide that. 72 divided by 12 is 6 centimetres per year on average. Obviously, not everybody grows the same amount every year, but that would be the average amount that he's growing each year over those 12 years. Okay. Wordy problems. Do we need to do wordy problems? All right. Okay, let's do a wordy problem. A triangle has a height and a base dimension of 3 to 7. Okay, sometimes it can be helpful if we put that 3 is representing the height of the triangle, and the 7 is representing the base. Because the order that it is in here, the height and the base, means the first number is the height and the second number is the base. If a particular triangle has a height of 9, what is the length of its base? This is an equivalent ratio question. If I have 3.7, actually I can use it down here, 3.7, and I know that my height is becoming a 9, how do I get from there to there? Times by 3. So if you times the 7 by 3, you get 21. So the base of that triangle would need to be 20, or maybe I should write that over here. Base is going to be equal to 21 centimeters. Okay, so often the wordy questions are using skills that you've already learnt, but just trying to get you to interpret what is going on, and then being able to do the math from there. So there's a few more wordy questions in there. Question 4, convert the following rates into the given units. 200 millilitres per minute into litres per hour. The way that I showed you of using the fraction can help you with this. You split it back up into the fraction. We put down 200 millilitres, and per minute means that's for 1 minute. By splitting the units up, it means that I can change this one into the litres that I want, and I can change that one into the hours that I want. Trying to change them both together is way too confusing, I think. Okay, so how do I change? Here's my new fraction. I want litres up here, and I want hours down there. How do I go from millilitres to litres? Not times. Divide by 1,000. There is 1,000 millilitres in a litre. So if I divide that by 1,000, you will get 0.2 litres. How do I get from minutes to hours? Divide by 60. And divide that by 60. Now this won't be very nice. 1 divided by 60. Ooh. So it can be better just to put that in as a fraction. It's 1/60th, 1 minute is 1/60th of an hour, okay? Decimal and fraction in my fraction, that's okay. My calculator can handle it. I can type in 0.2 over 1 over 60, not 16, 60, and there it is, 12. So I'm just using my calculator to divide those numbers. It is 12 litres per hour. Does that make sense? Split your units, millilitres per minute, change them both into the units that you want, divide the numbers, and you've got your final answer. Question 5. Calculate the average speed in kilometres per hour of a train travelling 480 kilometres in 6 hours. You may want to have this diagram written down somewhere. Speed is equal to distance over time. Okay, and in that triangle, you could find any of those 3 things. If you want to find time, you cover up the time, and it's distance over speed. If you want to find distance, you cover the distance, and it's speed times time, because they're next to each other. So if one's on top over the other, that's divide, distance over speed, but next to means times. All right, so I'm trying to do speed. So speed is equal to distance on top over time. Speed equals distance over time. Make sure that if we want kilometres per hour, it says I want kilometres per hour, that you need kilometres and hours here. So that one does. So have a look at the next one. Kilometres and minutes. So in this next one, you're going to have to convert that into hours before you put it in. But I'm doing the easy one apparently this time. So I have 480 kilometres, and that's done in 6 hours. So when you divide those numbers, 480 divided by 6, you get 80 kilometres per hour. Yeah? Okay, so I won't do B for you, but just remember to turn that 20 minutes into hours before you do it. So it's a third of an hour. That's 1/3 of an hour. Okay. All right, next one. Question C, let's do this because still using my triangle that I drew up too high, it says calculate the distance travelled. Go back to my triangle. Where's my triangle? I want distance. So it's going to be speed times by time. So distance equals speed times time. Okay, check your units. I have 8 meters per second. That's my speed, but it's in meters and seconds. Meters and seconds, meters and seconds. What is this? 2 minutes. I can't have minutes here and seconds over there. All right? For 2 minutes is the time, but I need it in seconds. Change this one. Don't try to change the one in the speed because then you've got the meters in there as well. Change the time one. So this one in seconds, you'll times it by 60. So it's 120 seconds. All right, then I can put it in my formula. My speed is 8, and I'm timesing that by 120. 960. 960 what? This is a distance. What is the units? So, I think I heard. Meters per second? It's not a speed. Meters per second is a speed. It is just the meters. Okay? The distance is the length unit. It's the meters. The time is the hours or seconds or the time unit. And it's only the speed that combines the two units to be meters per second or kilometers per hour. Does that make sense? All right, and D is a time taken one, but I better leave one for you to try. How many more do we have to do here? Oh, that's the last ones. That's it. Should we stop there and leave those ones for you? Yes, we should.